Thank you for having me here. Thank you, Andrew, for the kind introduction. So, as Andrew mentioned, I have a podcast where I often talk to people in a wide range of fields about what's going to happen with AI. And today I wanted to share with you what I think the full picture looks like, where my tentative guesses lie about both the pace of developments in AI and what their eventual impact will be when we get to AGI, however you want to define that. And so I just wanted to get a little bit in the weeds into what the timeline here looks like, what kinds of impacts we can expect. So as Andrew mentioned, I've had on a wide variety of guests to talk about where AI is headed. I've had on the CEOs of big AI labs and companies like Zuckerberg and Nadella and Dario Amodei, researchers like Ilya Sutskever. I've also had on, there's no domain of human knowledge which is not relevant to understanding what's going to happen with AI, because ultimately we're talking about what a future society of different kinds of beings will look like. So I've had on economists to talk about how you model the economic impacts of millions or potentially billions of extra people, of extra workers, which these AIs will be. I've even had on people who talk about primatology and trying to understand what had changed between chimpanzees and humans and what that might imply. You can look at the scaling laws in chimpanzee to human brains, and you can look at the AI models. And so I wanted to take some time with you all to see if we can come up with some synthesis between just different viewpoints. Because there is such a wide gap between some of the estimates people have had on my podcast. I've had on people who think we're more than 20 years away or 30 years away from this thing we call AGI. And what people often mean by this is the AIs which can do all of anything a human can do, at least as well as a human. A weaker benchmark for AGI is at least being able to do white collar work. So any job that you can do on a computer, an AI should be able to do. And then there's a question of when do we get to this point? What will happen when we get to this point? And people on my podcast have ranges anywhere from 30 years to 2 years. And I wanted to think through with you, because this is one of the most important questions of all time, when this happens, how this happens. So I wanted to see if we come up with some synthesis between all these different viewpoints today. So the first thing to talk about, and I think it's so easy to miss this, is how incredible the models we already have today are. We have models that can talk to you in human language, who are smarter than most experts in any domain of human knowledge. I don't know how much it's already shifted your work. For me personally, my work looks like a lot of research for future guests, future episodes in biology, AI, whatever. And it's shocking, just in a few years, we've gotten to the point where maybe half of my interactions with a computer are interacting with an LLM model. For those of you, I guess there's a hackathon going on right now as well. For those of you who are developers, you might have had the most salient experience of using these LLM models because you are interacting with them at what is one of their key competencies, which is coding. And so this feeling where you just have a model like Claude Code or Cursor code for 10 minutes, write entire applications for you just based on a spec you give it, including anticipating what kinds of features you would want, going through and debugging different issues. This is all possible today, and it's just incredible that we sort of gloss over the fact that we passed over the Turing test, and we can have AIs that can build these already act as sort of like junior front-end coders. But this raises a puzzle, which is that, look, why aren't they already more valuable in a purely economic sense? If you think about the world economy, let's say it's on the order of $100 trillion, 60% of that goes to wages, so that's $60 trillion that are paid to humans to do human work. That's a big total addressable market. And if we're talking about AGI here, AI should be able to have a meaningful fraction of that already. And if you look at the yearly running revenues of Anthropic or OpenAI, they're smaller than Kohl's, McDonald's, Jane Street, and many other firms which you don't think of as economically transformative in the way that we expect AIs to be economically transformative. So what gives here? Especially for the people who expect AGI very soon, how do they explain why these AIs haven't been economically transformative yet? So there's a couple of default explanations that people who are especially optimistic about AI have. And the first one is something like, look, if you go to a Fortune 500, it may be the case that one of those companies could be double digits more productive already if they integrated AIs through their stack, if they made a conscious effort to figure out what scaffolds and integrations they need in order to help their workflows, but it's just the management of these Fortune 500s is too stodgy. And so the AIs we already have, the models we already have are capable enough to be economically transformative, more transformative than, say, the internet. But these companies just aren't integrating them because of laziness or because of time delays, because they're stuck in the old paradigm. The other explanation, which is slightly more pessimistic, but still quite bullish on the models and the training techniques we have today, says that what we lack is just this final cherry on top data for things like computer use, which would make it more possible to automate much of white collar work. Because it's hard to do all that work just through a chat interface. You actually need to be able to integrate with computer UIs. But we just don't have the data for it yet, and we're very close to being able to get that data from getting these examples from chosen labelers who are doing sample white-collar work, so, just like reporting accountants while they're doing their work. Or at the very least, we could have the AI simulate these digital environments in which they could practice these tasks. But it's all possible with the training algorithms we have today. It's just a matter of collecting the remaining data. I think that neither of these explanations actually captures what the key bottlenecks are remaining for getting the truly transformative potential for AI. And that's why I have longer timelines to the kind of AI explosion that we'll talk about in a second. So bear with me while we get a little bit into the weeds of what I think are the bottlenecks of today's AI models, and then we'll have the big picture conversation about what will be possible once we get to the truly bullish future, which I think is coming. So I think the biggest bottleneck for these AIs today is the lack of continual learning, the lack of on-the-job learning. If you think about humans, if you have employees, or if you think about your own career, for the first 6 to 12 months, you were probably useless. I know I certainly was. And then you slowly start accumulating context, accumulating knowledge, which makes you more productive. If you think about what is it that makes a human employee productive or valuable, very little of that is just raw intellect. A lot of that is building up context in the workplace, interrogating your failures, picking up small efficiencies and improvements as you practice a task. And currently, AIs have no ability to do this. They have, over the course of a session, you can talk to these models, and at the end of 30 minutes of chatting with an LLM, you'll notice that you've saturated the context length, and you have to start a new session. And the new session has no memory of the last interaction you had with it. And I think this is a key bottleneck to making these models productive. I have probably spent on the order of 100 hours trying to get these LLMs to be useful to me in my post-production setup for my podcast. I'll try to get them to take in a transcript from auto-generated transcript for a podcast, and then make it more readable or find clips, a bunch of these little small tasks, which should be dead center in the repertoire of these LLMs, right? They're short horizon, language in, language out, pure text tasks. And the LLMs are, 5 out of 10 at these tasks, which is impressive, because I think most humans are not at a baseline of 5 out of 10 at a random task you give them. The problem is, with this task or any other task, you are stuck with current AIs with the abilities you get out of the box. So there's no way to give them high-level feedback, to have this organic process of improvement as they notice their own performance and get better over time. And I think this is just like fundamentally different from the capabilities humans have in improving over time. And a huge bottleneck into the economic potential of these AIs. It might be possible for them to automate various subtasks somewhat satisfactorily, but their ability to combine them together to get better over time will mean that you will still need to have human employees, even if you give them the data for white-collar work, if you have screen recordings of what different white-collar professionals do. They might do some subtasks well, but the fact that you can't treat them as an employee, give them feedback, will just mean that you won't get the true potential of AI. Now, people point out that we have already a couple of modalities with these AIs in order to give them feedback to have them improve. The most obvious and easiest one is system prompting, right? So you can tell the model, Here are a few examples of what it looks like to do this job or this task well. You can just put that into context. I don't think this is anywhere close to how humans learn and how they get better over time. I think it's orders of magnitude worse. Consider this example. How does a kid learn to play the saxophone? Well, initially they try to blow into one. They'll notice if it doesn't sound well, and it probably won't sound well the first time they try it. They'll adjust, and this process will go on. Now imagine this is the way you got to teach kids how to play the saxophone instead. A kid comes into the room, she tries to blow into the saxophone, doesn't sound so good, obviously. You send her away, and you write down on a piece of paper, look, I think the reason the last kid messed up is because they were messing with the reed in the wrong way, they didn't blow the right way. And you call the next kid who's waiting outside the room, you call them in, you give them this little piece of paper and you say, all right, now I want you to play a solo. Here's the instructions. No matter how well honed your written instructions are, there's just no way to get this tacit knowledge of how to play a saxophone. Teach that from just purely written text instructions, which is what system prompting is. I think this is true of many other jobs and tasks in the economy. You can't just like explain how to do it in a system prompt and how your AI has learned it. Then there's obviously other techniques like RL fine-tuning. So what you might try to do instead is to have an LLM try a task, and you just record, oh, did it succeed or did it fail? And then all of these LLM providers have ways in which you can give this labeled data to their API, or maybe you can train it yourself if you have an open source model, so that it learns from these examples. And in fact, if you played around with models like O1 or O3 or DeepSeek's R1, you've already seen the product of this kind of training. These models are incredibly good at math and coding because you can test math and coding at success. You can know if you solved the math problem correctly or if you passed the unit tests that were relevant to a certain coding challenge. So then you might wonder, could you do the same thing with all the other tasks in the economy? I still think this will not be possible because most tasks are not measurable or easy to break down in the way that the successes we've had with math and coding are. If I just think about the way I have video editors on my podcast, I think you can probably think of a relevant example in your workplace. There's just not a way in which I could set up some RL environment which teaches you how to clip content well and how to add music. I guess you could make relevant, bespoke environments for each of these subtasks. But the way in which human employees that, if you think about the way you've gotten better at a task, it's just you notice where things are failing. You can assign credit to different parts of the task that you think went well or not. It's a much more organic process than what just having like a number score on did this task go well or not. Now, of course, another thing you could try is just have the context window be longer so you don't have to escape the session. I think when GPT-4 was initially released more than 2 years ago, the context window was 8,000 tokens. And now we have models with million token context lengths, right? So the model is learning and active as an individual copy, not just a time short of intelligence, but as an individual copy for a much longer stretch of time, potentially for hours on end. And you could even have like a rolling context window. So a lot of coding assistants have, like Claude Code, if you play around with it, will work for an hour until they've saturated their context window. And then they'll compact it at the end. They'll summarize it in written language. Like, what did I do over the last hour? Then you restart that session. I think this works somewhat okay with coding because coding is very special in that the sense that code base is already a sort of external memory of the session. You have this artifact which compiles all your thoughts that you've had over the session. I think other domains of work just aren't this way, where we have a very legible, text-based a scaffold that you can refer to. And even within coding, at the end of session or after you've compacted, it will forget a lot of the tacit details about optimizations it made and it will reverse them. And it's a very fragile system. So I don't think this is a solution either. And I think what this means is that there's no obvious way to slot in this very crucial capability into the models of today, this on-the-job continual learning. There's no clear, obvious way in which models, the way they're trained today, can adapt its capability. Now, do I think this will eventually be available to these models? Yes. But because I don't think there's some clear way in which it happens tomorrow or next year, I just don't think we're going to see some transformative AGI emerge over the course of the next couple of years. I'll give my exact timelines in future slides, but I want to talk about another key capabilities these models are lacking, which is computer use. So as you know, these models, LLMs, they are mostly just text in, text out interfaces. And to really get more value out of them, eventually we'll get robotics and we'll get AIs that can actually move out in the real world. But much more immediate than that is the possibility that these AIs can use a computer as well as a human. Because when they can do that, they can actually do real white-collar jobs. And white-collar work is a significant fraction of the economy. I think there's been estimates by economists that upwards of 40% of labor is at least theoretically possible to do simply through remote work, just based on seeing how many jobs during COVID were able to become remote. And so then 40% of the economy is just huge, right? So what do we need to unlock this computer use so that we have access to this wider spectrum of task capabilities? I think this is also not a straightforward unlock for a couple of key reasons. Because sometimes people say, well, look, if you just record how an accountant does their job, how a programmer does their job, a bunch of other subtasks, like how an assistant uses the computer, you just train LLMs of today on this data, wouldn't you already have computer use very fast? I think this is challenging for a few reasons. One, we were very privileged with training LLMs in that the LLM is getting signal as it's learning from every single word it predicts. And it predicts trillions of words as it's training through its data set. With computer use tasks, with all kinds of agentic tasks in general, you have the problem that you have to go and operate a computer for hours on end before you get feedback. You got to book a flight, if you have to go file somebody's taxes. This is not something where you're immediately getting feedback every couple of minutes or seconds. This is something which you might have to work for 2 hours to get that feedback. And that's 2 hours in which you had to process computer tokens, not just pure text, which is more compute intensive. Second, we don't have this existing corpus of data, which we had, thankfully, for language in the form of internet text. Imagine if in the 1980s, you had all the compute in the world and you were told to make it the LLMs we have today. It might just not be possible because this fossil fuel of internet text data hadn't existed yet. And I think we're in a similar position with computer use. There's no corpus of people who are just recording how their jobs work in video format and then storing them on GitHub or something, which we have for code, obviously, not to mention for other kinds of text data. And furthermore, I just think that even simple algorithmic progress, if you just look over the last few years, has been harder than you might naively anticipate. If you look at 01, 03, DeepSeek's R1 paper explained how those models were trained, and it doesn't seem like a super complicated protocol, which of course it was, in that you had to prune a lot of alternative ideas to get at the final insight and had to do a lot of engineering. But even that, even going from GPT-4 to these reasoning models took 2 years, and now we're dealing with a totally different modality with computer use. You had to process video and images for much longer time horizons, using much sparser reward. I think that will just take longer than people anticipate. Okay, another key point is that over the last few years, we have been, I think over the last 10 years actually, we have been increasing the training compute of frontier AI systems 4x every year. So that's 160x over 4 years. This is a stupendous increase in how much the raw inputs of compute we're putting into training these systems, which actually explains most of the progress we've seen in AI. Most of it's not algorithmic progress. Most of it is just that we are dumping more and more compute every single year. This just physically cannot continue beyond 2030. There's detailed analyses which we don't have the time to go into, but if you look at raw energy uses, if you look at the fraction of leading edge wafers which are used for AI training, if you even look at the raw fraction of GDP that would have to be used in AI training, between all of those various inputs, the timeline suggested between 2028 to 2030, you really have to plateau this scale of compute, and then it had to go to all algorithmic progress, which is intrinsically much slower. So we are looking at a dynamic where it's closer to this decade to AGI or bust. And by bust, I just mean that it'll then we're looking at much longer timelines than, oh, it's happening right now, because every system every year is getting much better. All right, so this has been sort of a bearish forecast where I've been explaining why I'm not as optimistic as some of the most starry-eyed people who spend time with me in San Francisco. But it is worth considering that we already have models which are capable of actual reasoning. I don't think this is a facade or a mirage. I think there are genuinely reasoning. You can read reasoning traces of models like Gemini 2.5 Pro or DeepSeek R1 or OpenAI's O3, and it will actively be interrogating its environment, backtracking when it's noticed that it's made a wrong thought. I mean, how have we gotten used to this idea that you can just ask a machine a question, it will go away and think for 5 minutes, and think through different hypotheticals, think through different ideas, and come back to you with this really well-researched, deep answer to your question. It is just worth considering we are genuinely making progress towards AGI. This is a baby AGI. This is not some illusion. Okay, so where does this leave us? So here are my predictions. One thing you might hope that computer use gets us is end-to-end just dealing through Texas. I'm using this example because I think it's illustrative of a lot of the more boring tasks which are important in the economy and constitute a big amount of economic value, but we just gloss over for the more sexier use cases. So I have a small business, and I want an AI that is end-to-end able to go through my Amazon receipts, email people when it needs invoices, and haggle with them to make sure that things are in order. Do this over the course of a week, using the native computer use interface, using a computer screen, and just send the form to the IRS. I don't expect this sooner than 2028, for all the reasons we just talked about earlier. And continual learning, this on-the-job learning capacity, which I explained a little while earlier, this I expect by 2032, which is still quite close. Let's go to this, which is still quite close. So why only 7 years to this modality, which I don't think is there's even a path or a clear line of sight? Why is it only 7 years away? Well, if you think about how much time has passed between GPT-1 and O3, it's only been 7 years, right? So how much progress that you've noticed in AI has happened in this blink of an eye? I think it's totally possible to imagine that another 7 years could give us this key capability. And the reason why I think that's so important, continual learning is so important, is that I think continual learning not only gives us AGI, but gives us functionally superintelligence. And why is that? Well, when humans learn on the job, we are learning only the jobs that we are ourselves doing. The advantage these models have is that GPT-8 or GPT-10 or whatever model is doing this on-the-job learning, it can learn if be widely deployed through the economy, different kinds of jobs, and it can learn from the experience of every single one of its copies. So you have a single model which is learning basically how to do every single job in the economy. And even if there's no algorithmic progress beyond this point, just from this on-the-job training across the economy, I think you have something which functionally looks like an intelligence explosion. It looks like superintelligence, and that's not because the AI is helping train up future versions of itself. It's just this online continual learning. Just to fast forward a little bit, here's what this implies. I think new capabilities are coming, right? We've talked about two major unlocks, which are right down the pike. And if you just think about what has happened over the last few years, what has been possible with these new capabilities, think about, for example, Cursor. So Cursor was founded in 2022. It wasn't until 2024, when Claude 3.5 came out, which is really good at coding, that Cursor hit product market fit. And now we have these other huge unlocks that are coming down the line in the form of computer use, continual learning, many other things. I think it's still the case that it might even be too early when it comes to AI. I think people have this fear that, oh, I'm already late for AI, I should have started my company even earlier. But I think there's so many different applications of product market fit only once these key capabilities are unlocked. And so it's worth asking, what is the Cursor equivalent for these capabilities that we've just talked about? When these are unlocked, what new applications will be possible? And that's what I'd be working on today if I wasn't running a podcast. Anyways, thank you all for bearing with me. I appreciate it.